Hello guys, magandang araw sa inyong lahat. So, ipagpatuloy natin yung naudlot na discussion na nakaraan, no? So, dito, nag-start na ako sa thermal expansion ng water. Okay, so punta tayo sa slide number 20. Yan. So, thermal expansion of water. So, water in the temperature ranges of from 0 degrees to 4 degrees Celsius decrease in volume with increasing temperature. In this range, its coefficient of volume expansion is negative. So, above 4 degrees, water expand when heated. So, makikita natin dito sa diagram natin ito. Okay? So, dito. So, dito, water also expand when freezing, which is why ice comes up in the middle of the compartment and in an ice cube tray. So, by contrast, most material contract when they freeze. So, meron kasing merong special characteristic ang isang tubig, no? So, unang-una doon, kapag ang temperature range is from 0 to 4 degrees Celsius, is nagdi-decrease yung volume niya kapag nag increase yung temperature. So, makikita natin yan dito. Okay? So, from 0 to 4 daw, ang volume daw ng tubig is bumababa. So, nagsasag siya dito. Okay? So, kapag tumaas na ng 4 degrees, doon na siya ulit magsisimula na aakyat. Okay? Or mag-i-expand yung volume niya. So, meron siyang isa pang characteristic na kapag nag-freeze daw ang tubig, nag-i-expand yung kanyang or nag-i-expand yung kanyang volume. Okay? So, ito yung dahilan kung bakit pag gumagawa tayo ng mga ice cube dun sa natin sa ref is madali siyang matanggal kasi nag-e-expand siya. Okay? So this is anomalous behavior of water has an important effect on plants and animal in lakes or other bodies of water. So a lake cools from the surface below from 0 degrees. The cold water at the surface flows to the bottom because of its great density. Okay? But when the surface temperature drops below 4 degrees, the water near the surface is less dense than the warmer water below. So, hence, the downward flow ceases. And the water near the surface remain colder than the water below. So, as the surface freezes, the ice floats because it less dense than water. Umiibabaw yung tubig. So, ito yung mga anomalous behavior ng isang water. So, tatandaan lang natin tong graph na to. Okay? So, punta tayo ngayon sa thermal stress. Okay? So, yung thermal stress kasi is nangyayari, kung natatandaan nyo, yung last time na topic natin is thermal expansion. So, kapag meron tayong kunwari, metal, isa tong metal, no? Pag meron siyang gap dito, wala siyang thermal stress. Okay? So, paano siya nagkakaroon ng thermal stress? So, kapag meron tayong dalawang metal na magkadikit, katulad nito, ayan. So, dito sa part na to is magkakaroon ngayon ng thermal stress. Okay? Kasi, di ba meron tayong thermal expansion? Pag ganito yung figure natin ng metal, pag nagkaroon ng thermal expansion, kunwari, is, yung length nitong metal na 'to is humaba ng ganyan at ito naman ay humaba ng gano'n, meron siyang gap, meron siyang allowance. Pero 'pag ganito, ang nangyayari is nagkakaroon siya ng stress dito. 'Yun ang tinatawag na thermal stress. Okay? So, yung thermal stress natin is meron tayong formula, no, na F/A is equal to negative Y alpha change in temperature. Ayun. So, paano yan na-derive? So, na-derive yan using an experiment, no? So, to calculate the thermal stress and clamp rod, so for example, meron tayong clamp rod, no? We compute the amount that rod would expand or contract if held when defined stress needed to compress or stretch it it back to its original length. Suppose that a rod length LO, so kunwari meron tayong rod dito. Ako, bakit lumaki? Anong nangyari? So kunwari meron tayong rod dito, no? Tapos yung rod na yon is merong LO or initial length. Ayan. And cross-sectional area A. So, meron tayo ditong A, yung cross-sectional area niya, no? Is held a constant length while the temperature is reduced. So, magkakaroon tayo ng reduce ng temperature cause a tensile stress. So, magkakaroon daw to ng tensile stress dyan. So, the fraction change in length if the rod were freely contract would be, so, yung fractional changes daw ng length ng rod kapag freely siya, walang harang, is magiging change of length over the initial length. This is thermal is equal to alpha change of temperature. Okay? So, both A, change in L and T are negative. Okay? Kasi tension. The tension must increase by amount F that is just enough to produce an equal opposite fractional changes in length. Okay? So, meron kasi tayong tinatawag na Young modulus. Okay? Equation ng Young modulus. So, mangyayari dito, teka, maganda is pakita ko sa inyo yung equation ng Young modulus. Hanapin ko lang. Ang Young modulus kasi, yan, gawin kong red. Ang Young modulus kasi is Y is equal to tensile stress over the tensile strain. So, kadalasan ginagamit to doon sa strength of material. So, i-advance na natin ng konti. Okay? So, this is equal to F over A over the change of length over initial. Okay? So, galing dito, pwede nating sabihin na F LO over A Mali. Teka, ayusin natin. So, magiging F, initial L, A, ito, multiply by the change of L. Ayan. So, ito yung formula ng Young modulus. So, balik tayo dun sa atin. So, dito naman sa atin, Y is equal to FA, yung kanina, FA, magiging change of L, over to, may over yan. Change of L over initial L. So, pwede nating masabi na change of L over initial L or length na tension is equal to F over A Y. Ayun. Okay. So, if the length is constant, the total fractional change in length must be 0. Okay? So, ano mangyayari ngayon? Kung ganun, i-equate natin so ng change of L over LO na thermal, yung galing sa formula natin kanina, plus change of L, LO, or initial length, pero ito naman is tension, is equal to alpha, change in temperature, plus F over AY. Equate natin to sa 0 kasi nga, yung change ng length natin is magiging 0. Okay? Must be 0. So, solving the tensile stress F over A, no? Kung isosolve natin ngayon yung F over A using algebra, ang lalabas dito pag sinimplify natin yan, magiging negative Y alpha change of temperature. So, ito yung magiging thermal stress natin. Na ipinakita naman sa ating ito siya. Okay, thermal stress. So, mas maganda yan kung meron tayong example. Yan. So, dito sa example na to, an aluminum cylinder of 10 cm long with a cross-sectional area of 20 cm squared is used as a spacer between two steel wall. At 17.2 degrees Celsius, it just clips between the walls. Calculate the stress in the cylinder and the total force it exerts on each wall when it's warm to 22.3 degrees Celsius. Assume that the walls are perfectly rigid and the constant distance apart. So, ano yung scenario natin dito? So, meron daw cylinder na aluminum, made of aluminum na 10 cm. Tapos meron siyang cross-sectional area of 20 cm squared. Ginamit siyang spacer between two steel wall, no? So, nung una, merong temperature na 7.2 degrees Celsius nung inilagay siya doon sa wall na yon. So, after naging 22.3 degrees Celsius siya, i-calculate natin yung stress in the cylinder and the total force na in-exert nung wall. So, assume lang natin na yung wall is perfectly rigid and constant distance apart. So, ibig sabihin, hindi gagalaw yung wall na yon kahit pagpilitan ng cylinder na humaba. Okay? So, paano natin siya i-approach? So, this is problem number, di ako nagkakamali, this is problem number 4. Okay? Problem number 4. Ayan. So, maganda dito is drawing na muna natin. Okay? Kunwari, meron akong dalawang wall, no? Ayan. Meron ako ditong dalawang wall. Tapos, rigid yung wall na yun, no? Rigid to. Sabihin na rigid, hindi siya mawawasak. Matibay siya. Okay? Tapos, meron tayong aluminum cylinder. Kunwari, ito na lang. Yan, ito yung aluminum cylinder natin ngayon. Ayan. So, ito daw is merong cross-sectional area. No? So, dito muna tayo. Ang length daw nung cylinder na ipinasok is 10 cm. Okay? 10 cm daw yan. Tapos, ito daw is merong cross-sectional area na 20 square centimeter. Okay. So, meron tayong initial temperature dito, no? Meron tayong T1 or sabihin natin T initial is equal to 17.2 degrees Celsius. Tapos, meron tayong T final na 22.3 degrees Celsius. Okay. So, ang hahanapin natin dito is yung stress in the cylinder tapos yung force na ini-exert ng dalawang wall. Okay? So, una, meron tayong modulus of elasticity. Hindi. Modulus, yung kanina, ang tawag doon? Yung Y. Meron tayong yang modulus nung aluminum. Okay? So, ibibigay ko naman tong libro sa inyo. Hanapin nyo yung table. May mga table dyan ng yang modulus. I-upload ko to sa Leons ngayon. Yan. So, dito meron tayong Y ng aluminum. No? Ang Y ng aluminum kasi is 7.0 times 10. 10 yan raised to 10. Pascal. Ayan. So, meron naman tayong alpha ng aluminum na 2.4 times 10 raised to negative 5. Negative Kelvin. So, dito makukuha na natin yung tinatawag na, pag ginamit mo tong dalawang to, makukuha natin yung change in temperature. So, yung change in temperature niya is 22.3 minus 17.2. So, calculator tayo. 22.3 minus 17.2. So, magiging 5.1 to. Degrees Celsius. Okay. Ayun. So, this is equal to rin to 5.1. Sabihin natin, Kelvin. So, gagamitin natin yung formula kanina, no? Ayan. So, yung formula ang gagamitin natin is yung F over A is equal to negative Y. Aluminum to, no? So, huwag na natin lagyan ng aluminum. Ay, hindi. Kailangan natin lagyan kasi dalawang material pala to. Tapos, alpha ng aluminum multiply ng change of temperature. So, pwede nating ipasok, no? Pwede natin siyang ipasok. Meron tayong 7.0 times 10 raised to 10 multiply by 2.4 times 10 raised to 5. Change of temperature natin is 5.1. Seven point zero times 10 raised to 10 tapos 2.4 times 10 raised to negative 5 multiply by 5.1. Ang lalabas is negative 8.6. May negative to. Magiging negative 8.6 times 10 raised to 6th power. So, Pascal. So, paano naging Pascal yan? So, kasi, ang unit nito, Pascal. Ang unit nito, multiply yan, no? Ang unit nito is K, negative 1. Ito is K. So, ito kasing K, negative 1, pwede nating sabihin na 1 over K. Multiply ng K, makaka-cancel out. So, matitira, Pascal. Kaya Pascal to. Okay? So, pwede natin tong i-convert ng, yung Pascal kasi is pwede natin i-convert ng pounds per square inches. Okay? Paano conversion? So, paano natin i-convert? So, i-convert natin yung Pascal to PSI. So, ang conversion factor na gagamitin natin is 1 PSI. Ito na lang na. Conversion factor is 1 PSI is equal to 6894.75 PSI. Hindi. Sorry. PSI yung nasa isip ko. This is Pascal. So, i-convert natin, no? Magiging negative 8.6 times 10 raised to 6 na lang. Raised to 6 yan. PA. Multiply natin ng 689475.75 PA. So, PSI to. So, cancel to. Matitira. PSI. So, ang lalabas dyan, negative 8.6 times 10 raised to 6 times 1 over 6894.75. So, ang lalabas is negative 1247. Okay? Negative 1247.33. Or pwede nating i-approximate na 1,200 pound per inch, square inches. O dito. Ayan, PSI. Okay. So, ito na ngayon, yung stress doon. Ito yung stress na mararanasan. Okay? Doon sa cylinder. Dito. Yung stress na binibigay dyan. Oh. Tapos, ang susunod nating problem is yun namang total force exerted by the walls. So, yung yung force na binibigay dito. Okay? So, dito, madali na lang to, no? So, para makuha natin yung force na yun, nandito na siya eh. Nandito na yung formula eh. Ito yung stress, kukunin na lang natin yung force. Okay? So, yung first natin, equals to area. Tapos, ito. F over A. Okay? So, yung area, ibinigay niya na, no? So, yung area is ibinigay niya na 20 square centimeter. No? So, i-convert natin yun ng meter. So, pag i-convert natin yan ng meter, magiging 20 times 10 raised to negative 4. No? Tapos, yung FA, ito siya, negative 1,200 pounds square inches. Ayan. Ito. So, calculator. Magiging 20 times 10 raised to negative 4 multiplied by negative 1,200. Ang lalabas dyan is hindi. Ang gagamitin pala natin dito hindi yung 1,800. Gamitin natin dito is yung 8.6 times 10 raised to 6. Okay? So, negative 1.7 or 17,200 or magiging negative 1.7 times 10 raised to 4 Newton. Or equivalent niyan is 1.9 tons. So, negative means papasok yung force. Okay? So, this is our answer dun sa pangalawang tanong dun sa example number 4. So, ayan siya. Okay? Sa presentation. Okay, na yan. So, pasok tayo dito sa tinatawag na quantity of heat. Okay? So, kunwari naglagay tayo ng malamig na, kutsara do'n sa mainit na kape. So, sa mga may hilig magkape diyan, ito para sa inyo, 'no. So, kunwari yung kutsara na 'yun is nilagay ko sa ref ng ilang oras. Siyempre malamig yung spoon na 'yun. So, kapag inilagay ko sa kape na mainit, yung spoon is magsisimulang uminit, okey? And yung kape naman is magkakaroon ng cool down para ma-approach nila yung tinatawag na thermal equilibrium. So, the interaction that cause the temperature changes in the fundamental a transfer of energy from one substance to another. Okay? So, yung interaction daw na yun is nagkakaroon ng changes ng temperature or yung tinatawag nating transfer of energy from other substance to the other. So, the energy transfer that takes place solely because of temperature difference is called heat flow or heat transfer. Okay? Dito na tinatawag nating heat transfer. And the energy transferred in this way is called heat. Okay? So, an understanding of relationship between heat and other forms of energy emerged during the 18th and 19th century. So, yung pagkakaroon daw ng difference ng init ng forms of energy is napag-aralan nung 18 to 19th century. So, isang ano dito, ang isang tao na talagang tinutukan niya yung pag-aaral na to ay si Sir James Joule. So, siya ay nabuhay ng 1918 to 1989. So, pinag-aralan niya yung mainit na tubig na yung mainit na tubig na yon is kaya makapagpagalaw ng isang paddle wheel. Okay? So, ganito siya. Okay? So, nakita niya na the paddle wheel adds energy to the water by doing work on it. Okay? So, sabi niya, kapag yung paddle wheel daw ay inikot ng inikot, yung tubig sa loob ay umiinit. Okay? So, sabi ni Sir James Joule that the temperature rise is directly proportional to the amount of work. Okay? So, yung pagtaas daw ng temperatura ng tubig is directly proportional sa work na ginawa mo doon. Okay? So, the same temperature changes can also be caused by putting the water in contact with some hotter body. Okay? Hence, an interaction must have involve an energy exchange. So, we will explore the relationship of heat and mechanical energy doon sa ating susunod na topics, no? So, tingnan na lang natin 'yan. So, dito pala, nagkaroon tayo ng tinatawag na conversion. So, we can define unit of quantity of heat based on temperature changes from some specific material. So, dito, lumabas yung tinatawag na calorie or kadalasan nating tinatawag na cal. Okay? This is defined as amount of heat required to raise the temperature of 1 gram of water from 14.5 degrees to 15.5 degrees. So, si calorie daw, siya yung amount ng heat na kailangan nating ilagay sa tubig, 1 gram of water, para makapag-rise siya ng from 14.5 to 15.5 degrees Celsius. So, yung kilocalorie naman is yung 1,000 calorie. So, ito yung ginagamit sa mga pagkain. Okay? So, yung 1 kilocalorie is equal to 4,186 joules. Okay? So, madali lang i-convert yung cal to joules, no? Is equal to 4.186 lang yung 1 calorie. So, a corresponding unit naman of heat using Fahrenheit degrees and British unit is yung tinatawag na British Thermal Unit or BTU. So 1 BTU is the quantity of heat required to raise the temperature of 1 pound of water from 1 Fahrenheit, water 1 Fahrenheit. So from 63 degrees Fahrenheit to 64 degrees Fahrenheit. Yung ano daw, yung BTU naman daw is yung heat required para uminit yung 1 pound ng water from 63 Fahrenheit, degrees Fahrenheit to 64 degrees Fahrenheit. So because heat is energy in transit, there must be between relationship these units. So in familiar mechanical energy units such as joules. So ito yung mga, kung makikita nyo dito sa screen, ito yung mga conversion niya. Okay. So yung SI unit ng heat transfer is yung calorie. So the International Committee on Weights and Measurement recommend it's using the joule as the basic unit of energy in all form. So including heat. So yun naman yung ire-recommend natin dito sa slide na to. So pasok din tayo dito sa tinatawag na specific heat. So we use the symbol Q for quantity of heat. Okay? When it's associated with an infinitesimal temperature changes, infinitesimal temperature changes na derivative of T or dt, we can call dq. We call it dq or derivative of q. So the quantity of heat Q required to increase the temperature of a mass M for a certain material from the temperature T1 to T2 is found to be approximately proportional to the temperature changes of T1 minus T2 minus T1. So dito, formulang gagamitin natin is Q equals to MC change of temperature or alpha delta T. So kami noon nung nagre-review kami, ang ginagamit namin dito pag specific heat ang pinag-uusapan, ang hindi naaalis sa utak namin is si MCAT. So madali lang tandaan, Q equals to MCAT or MC is equal Q equals to MC multiplied by the change of temperature. Okay? So dito, pwede nating palabasin si C. Okay? So pag dinerivative kasi natin yung Q or derivative of Q, ang lalabas niyan is MC derivative of T. Okay? So pag inayos natin to, si C, papalabasin natin, ang lalabas niyan is 1 over M derivative of Q over dt. So ito yung tinatawag na specific heat. Okay? So punta tayo ngayon sa example para mas makakuha natin. Example number 5. Feed a cold starved fever. So sabi dito, during a boat with the flu, an 80 kilogram man ran a fever of 39 degrees Celsius or 102.2 degrees Fahrenheit. So instead of the normal body temperature na 37 degrees Celsius, so assume the human body is mostly water, how much heat is required to raise the temperature by the amount. So dito hanapin natin yung ilang gaano daw kanaming heat yung nire-required para mapataas natin yung temperature from 37 degrees Celsius to 39 doon sa pasyente nating nilalagnat. So, paano natin siya i-approach? So, yung problema to is gumagamit ng relationship between um, among heat, no? Yung problem na to daw is merong uses the relationship ng heat mass specific heat and temperature changes. So dito pwede nating gamitin yung equation na MCAT, no? So this is problem number 5. So dito pwede nating gamitin yung formulang Q is equal to MCAT. Ayan. No? So, para ma-determine natin yung Q. So, meron tayong M. Yung M natin is, sorry, napindot ko. M is equal to 80 kilogram. Okay? So, yung C naman natin, dahil sinabi niya na yung body daw is mostly water, meron tayong constant ng water na 4190 joules kilogram Kelvin. Yung C natin, constant. So, yung change of temperature natin is magiging 39 minus 37. So, is 2 degrees Celsius or 2 Kelvin. So, dito, papasok lang natin dito sa formulang to, no? Madali lang siya. Q is equal to M or 80 kilogram. Multiply lang natin ng 4190 which is C. Tapos, multiply natin ng 2. So, dito lalabas is, calculator natin, 80 times 4190 times 2. Ang lalabas ngayon is ilan yan? 6.7? 6.7 times 10 raised to 5th power. Galing, no? Yung 3 naging 5. Yan. So, the 5th power, joule na ngayon, yung ano natin, unit. Okay? So, ito yung answer natin doon sa problem na yun. So, example number 6. Pasok tayo dito sa overheating electronics. So, paborito natin to. Electronics to eh. So, you are designed an electronic circuit element made of 23 milligram of silicon. The electric current through it adds energy at the rate of 7.4 megawatts. Or equals to 7.4 times 10 raised to negative 3 joules per second. If your design doesn't allow any heat transfer out of the element, at what rate that its temperature increase. So, the specific heat of the silicon is 705 joule over kilogram Kelvin. So, paano natin i-approach to? 705 yan, ha? So, this is problem number 6. Okay? So, the energy added to the circuit element gives the rises to a temperature increase. So, dahil nagbigay tayo ng energy, doon sa circuit natin, magkakaroon siya ng rise of temperature. So, just as if heat we're flowing into the element at the rate of dq over dt, no? So, pwede nating sabihin na yung dq over dt niya is yung yung energy na binibigay natin, no? So, dq over dt, or yan, tama, is equal to 7.4 times 10 raised to negative 3 joules per second. So, ang target variable natin is yung rate of temperature. So, kailangan nating hanapin dito yung dt over temperature yan, no? Over time. So, ang gagamitin nating equation dito is yung pwede nating gamitin yung derivative of q is equal to mc. Oops, sorry. Pindot ko na naman. mc dt. No? Ayun. Tama? Tama ba? So, dito, ang mangyayari is magiging dt or derivative of temperature over the derivative of time is equal ngayon to sa derivative of q over derivative of time over mc, no? Or meron tayong dq over dt na 7.4 times 10 raised to negative 3 over yung mass natin daw is 23 milligram. So, convert natin siya sa kilogram, no? Pag kinonvert ko sa kilogram, magiging 23 times 10 raised to 6 kilogram na to. Multiply by 705. So, analyze natin to, no? Ito is joules per second. Ito naman is kilogram. Ito naman is joule over kilogram Kelvin. Okay? Yung kilogram mawawala na. Yung joule is mawawala na. So, matitira is kilogram per second. So, ang lalabas dapat dito is K over S. Ayun. So, using your calculator, lalabas yung answer dyan. So, 7.4 times 10 raised to negative 3. Tapos, 23 times 10 raised to negative 6. Multiply by 705. Multiply by 8. Ay, hindi na, wala pala. So, ang lalabas dito is 0.45 or 0.46 Kelvin second. So, this is our answer. So, ito yung tinatawag na rate ng temperature increase. Okay? 0.46. So, ayan. So, pasok naman tayo dito sa tinatawag na molar heat capacity. No? So, yung molar heat capacity is merong formula na Q equals to NC. Kung kanina, N ay M. Ito naman, NC. Okay? So, sometimes it's more convenient to describe a quantity of substance in terms of the number of moles. So, yung letter N dito is number of moles than the mass M of a material. So, pwede natin itong i-recall dun sa chemistry natin. Okay? So, the molar mass of a substance, noted M, is naka-mass per mole. Okay? The quantity M is sometimes called molar weight, but molar mass is preferable. So, the quantity depends on the mass of molecule, not its weight. So, for example, meron tayong molar mass of water na 18.0 gram per mole is magiging 18 times 10 raised to negative 3 kilogram mole. So, 1 mole of water has a mass of 18 grams or 0.0180 grams. So, mas maganda gayon. Mas maganda ako nandito. So, for example, the molar mass of water no is 18. 18 gram per mole. So, kung i-convert natin to ng kilogram, no, magiging 18 times 10 raised to negative 3 kilogram mole. So, 1 mole of water is merong mass na 18 grams. Pwede nating masabi na meron siyang 0.018 kilogram yung 1 mole of water. So, the total mass na M of material is equal to the mass per mole na M na malaki times the number of moles. So, pwede na daw nating sabihin na M, maliit na M, is equal to N over malaking M. No? So, yung maliit na M is yung mass ng material. Ito naman is yung mass per mole. Ito naman yung number of mole. Okay? So, i-replace lang natin, no, yung formula kanina. Wait lang, hanapin ko lang yung formula. So, yung formula kanina nung ano natin, nung specific heat, yung Q. Yung Q is equal to MC MCAT. So ngayon, i-replace natin tong maliit na M nitong malaking M saka number of mole. So magiging Q is equal to N malaking M change ng temperature. Okay? So the product MC, no, or yung tinatawag na molar heat capacity, and is denoted by C, capitalized C. So pwede natin tong i-rewrite. Nawala pala yung C dito, no? So, ito daw, itong MC na to is pwede nating i-rewrite na malaking C. Kasi ito yung daw yung tinatawag na molar heat capacity. So, pag ginawa natin yan, yung Q natin is magiging N, malaking C, change of temperature. Ito naman, yung makikita nyo dito. Ayan, sa quantity of heat. So, dito is meron tayong approximate specific heat and molar heat capacity na nasa constant pressure. So, ayan yung table. So, pasok ngayon tayo dito sa tinatawag na calorimeter or calorimetry and phase changes. So, calorimetry means measuring heat. So, yun daw yung meaning ng calorimetry. No? We have discussed the energy transfer heat involved in temperature changes. Heat is also involved in phase changes such as the melting of ice or boiling of water. Once we understand this additional heat relationship, we can analyze a variety of problem involving quantity of heat. So, pasok tayo dito sa tinatawag na phase changes, no? We use the term phase to describe a specific state of matter. So, nung elementary tayo, ang alam lang natin na phase is liquid, solid, and gas. Meron tang pumasok na mga plasma, yung mga ganun, no? So, dito, such as solid, liquid, gas, kunwari, the compound H2O o water exists in the solid space as ice. In the liquid space naman, tinatawag siyang water. In the gaseous space naman, tinatawag siyang steam or yung nag-evaporate na. No? There are also referred as state of matter na solid state, liquid state, and gaseous state. So, a transition form of one phase to another is called phase change or phase transition. For any given pressure, a phase changes takes place at definite temperature, usually accompanied by absorption or emission of heat and change of volume and density. So, a familiar example, no, ng phase changes is yung pagtutunaw ng yelo or melting of ice. When we add heat to ice at 0 degrees Celsius and a normal atmospheric pressure, the temperature of ice does not increase. Okay? Instead, some of it melts to form liquid water. So, kunwari, meron tayong yelo tapos naglagay tayo ng temperature or heat doon sa ice. So, yung iba doon is matutunaw at magiging liquid water. So, if we add the heat slowly to maintain the system very close to thermal equilibrium, the temperature remains at 0 degrees until the ice melted. Okay? So, the effect of adding heat to the system is not to raise its temperature but to change its phase from solid to liquid. So, to change 1 kilogram of ice at 0 degrees Celsius to 1 kilogram of liquid ice at 0 degrees and a normal atmospheric pressure, it requires 3.34 times 10 raised to 5 heat. No? So, para daw makapagtunaw tayo ng 1 kilogram ng ice para maging liquid na water, tandaan na 1 kilogram din to. Yung energy na ipapasok natin dito is equal or yung heat na ipapasok natin dito is 3.34 times 10 raised to 5 joules. So, yan. The heat required per unit mass is called the heat fusion. Or sometimes, natawag nating latent heat fusion. So, yung latent heat fusion is kadalasan tinatawag na LF, no? So ito is latent heat fusion ang tawag dito. Ayan. For water at normal atmospheric pressure, the heat of fusion is for the water, no? Yung water, ayan, umiiyak na yung anak ko. Nagising na. Yung LF daw is equal to 3.34 times 10. Pasensyahan nyo na kung mayroong background na nag-iiyak dyan. Kilogram or equals to 79.6 calorie over grams. Or pag-convert natin to is I love you BTU. Yeah, matatandaan natin yan ng mabuti. So, wait lang guys. Ayusin ko lang muna anak ko ah. Mabilis lang.